previous week, we talked about interpolation and numerical differentiation. In this week, we'll talk about integration. The connection between interpolation and numerical differentiation is that in numerical method, differentiation is conducted over discrete point. However, in theory of calculus, differentiation is all about continuous functions. So interpolation is used to make this discrete point a continuous function, and then we apply differentiation. The same approach will also follow here. The main problem of numerical integration is that here the integration is over discrete points, not over a function. We'll see how to conduct these integrations. And then we'll apply this idea in solving some interesting problems. In this week, apart from the usual theoretical part, we will have quite a few programming. In the lecture, I'll show you how to write programs for numerical integration to solve actual application. We'll do that for usual integration as well as for double integration, which has advanced application in finding area, volume, mass, or similar quantities of interest. Also, in this week, we will use both usual Python as well as scientific Python package. I'll show you some use of that in numerical calculation. So altogether, this is going to be a very fruitful and illuminating week for all of us. As we go from analytical to numerical integration, there are certain fundamental differences that we have to understand. Analytical integrations are conducted over functions, but numerical integration we will conduct over discrete points. So how do you integrate discrete points? So it's a two-step process. Step 1 is we use the technique that we have learned in interpolation, specifically this Lagrange polynomial interpolation, and we try to fit a polynomial through these discrete points. Once we have the polynomial, in step 2, we integrate the polynomial using usual analytical techniques. Integrating polynomials are actually very easy analytically. We can integrate analytically, and then that will get a prescription of how we can evaluate the integration for these discrete points. Now from this, it should be very clear to you that knowledge of interpolation is central in evaluating numerical integrals. Like all numerical methods, this will also give you at the end certain formula or certain procedure to calculate integral. But the theory comes from here. That is interpolation. You will not understand how integrals are performed until you understand interpolation, especially this Lagrange polynomial. Another point that is very important is that numerical calculation can only give us numbers. Therefore, numerical integration can only give us definite integral. The output of numerical integration will always be numbers and not a function. In the overall scheme of this course, we have completed this week 1 to 5. That means some preliminary discussion, root finding, then the programming part, then the linear algebra. We have completed this portion. Now we are in calculus. In calculus also we have completed the interpolation part, and here we are in the integration part. The next part will be ordinary differential equation. From integration we will move toward ordinary differential equation, then eventually partial differential equation. After the partial differential equation we will conclude the calculus part with modeling and solving practical problems. So this top part is completed and this part is about to come. This week we will primarily focus on the integration. We will see that we may introduce some ODE or not, but it will be mostly about integration. Thank you, and that's all for now. Happy learning.